Hi GOH, this is Circles, lesson 13, and this is the last lesson, and today we're going to talk about equations of tangent lines. So remember back when we defined tangent lines, when we first started circles, a tangent line is a line that intersects a circle in one spot only. Okay, so let's look at exercise 1. Given line segment AB with endpoints at A and B, answer the following questions. We're going to find the slope of AB. So remember, slope is the change in y over the change in x. So we're going to take our y's, we're going to subtract them. That goes on top, 6 minus negative 3. We're going to take our x's and subtract them. That goes on the bottom, 3 minus negative 3. Remember, a minus negative is a plus positive. So I have 9 over 6, and I want to simplify that. So those are both divisible by 3. So I'm going to get 3 halves. Okay. Part B, determine the slope of a line perpendicular to AB. All right, so that got on the, for some reason that got all the way over there. So we don't want that over there. Perpendicular to AB. Well, you guys remember perpendicular lines, the slopes are negative reciprocals. All right, so perpendicular slope, I'm going to take that 3 halves, I'm going to flip it, and I'm going to change the sign. All right, so that's the slope of a line that's perpendicular to AB. Now I want to write an equation of a line that passes through point B, and that's perpendicular to AB. So this is my equation of a line. I need 2 things to write the equation of a line. I need a point and a slope. Now the point I have, that's point B. That's going to be this point up here, 3, 6. The slope I have, it's going to be my perpendicular slope, which is right here, negative 2/3. So I have a point and a slope. So here we go. Y minus 6 equals negative 2/3 x minus 3. Okay, so that's the first part. The second part wants me to find out the y-intercept of this line. Well, in order to get the y-intercept of that line, all I'm going to do is I'm going to take it and I'm going to put it into slope-intercept form. So I'm just going to distribute that negative 2/3 to everything inside the parentheses. All right, so it's going to be y minus 6 equals negative 2/3 x. And negative 2/3 times negative 3 is, let's see, positive 2. And then I'm going to add 6. So once it's in this form, I can easily see that my y-intercept is that 8. Remember, y equals mx plus b, so my y-intercept is 8. Where am I going to write that? I'll write that right here. Y-intercept equals 8. Okay, that was the first one. Now let's apply this to circles. So in circle A, shown below, with the center at the origin and a radius of 5, point B lies on the circle and has coordinates of 4, 3. The tangent to the circle at point B is drawn. Write an equation of the circle below and show that 4, 3 must lie on it. All right, so equation of a circle. So this will be a good review for us. That's the equation of a circle where the center is the origin. All right, so our radius is 5, so it's just going to be x squared plus y squared equals 5 squared, which is 25. Now I want to show that the point 4, 3 lies on that circle, so I'm going to plug in 4 for x, and I'm going to plug in 3 for y. 4 squared is 16, 3 squared is 9. Yep, it sure does. The point 4, 3 lies on that circle. Great. Now I want to find the slope of AB. Okay, well, A is the center, 0, 0. B is the point 4, 3. So I'm just going to find the slope. So change in y, that goes on top, 3 minus 0. Change in x, that goes on the bottom. All right, 3/4. So far, so good. Write the equation of line M in point slope form. Now remember, line M is tangent. So that means I need the perpendicular slope. So the perpendicular slope is going to be negative 4/3. So I'm going to take this perpendicular slope and I'm going to take point B, and that's what I'm going to use in my point slope form. So y minus 3 equals negative 4/3 x minus 4. It appears that line M has a y-intercept of 8. Prove or disprove this observation. All right, so if I want to, I would have to take my equation of a line, all right, and I would have to distribute that negative 4/3 to everything in the parentheses. So I'm going to have y minus 3 equals negative 4/3 x minus, and actually it's going to be plus 16/3. Now this doesn't go in evenly, so I'm just leaving that as a fraction right there. Now if I want to combine it with the 3, I'm adding 3, but I can't add 3 unless it has the same denominator. Remember, you can't add fractions unless the denominator is the same. So basically, instead of adding 3, I'm going to add 9/3 because 9/3 is equivalent to 3. And when I add 9/3, that's actually 25/3. So I get y equals negative 4/3 x plus 25/3. Well, that doesn't go in evenly, so it definitely does not have a y-intercept of 8. 25 divided by 3 is 8 1/3, so it's close. All right, but it does not have a y-intercept of 8. No, would be my answer. Okay? All right, next page. The key to writing these equations is the fact that the tangent will be perpendicular to the radius at the point of tangency, and that's a rule that we learned in the first half of this circle chapter. Thus, the tangent and radius will have slopes that are negative reciprocals. So consider the circle whose equation is x minus 6 squared plus y plus 3 squared equals 80 and the point 25. Use of the grid is optional, but helpful to visualize what is happening to the problem. All right, so the center of the circle is going to be 6, negative 3, okay? And my radius is going to be radical 80, which is almost 9. It's like 8.9, okay? So 6, negative 3, and again, they said I didn't have to do this, and it has a radius of almost 9. So that means I'd be going 1, 2, 3, 4, 5, 6, 7, 8, 9 in this direction, almost. And then 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I don't know, it looks something like this. All right, and going that way too. Let's see. So the point 25, so 2, 1, 2, 3, 4, 5. Show that A must lie on this circle. All right, well, in order to do that, I'm just going to take my equation, which is x minus 6 squared plus y plus 3 squared equals 80, and I'm going to plug in point A. So point A was 2, 5. So I'm going to plug in 2 for x and 5 for y. So 2 minus 6 is negative 4, but remember I'm squaring it. 5 plus 3 is 8. Negative 4 squared is 16. 8 squared is 64. And yep, 80 equals 80. Perfect, so that point lies on there. Find the slope of the line segment that connects the center of the circle to point A. So point A is right here. So I want to find the slope of, I'll do it in a different color for us. I want to do the slope of that line that connects point A to the center of the circle. So A is 2, 5, and the center of the circle, which I'll call C, is 6, negative 3. So the slope is going to be negative 3 minus 5, I'm subtracting the y's, 6 minus 2, I'm subtracting the x's. So negative 8 over 4, which is negative 2. Okay? Write an equation of the tangent line to the circle at point A. So remember, tangent is perpendicular, so I need my perpendicular slope. So perpendicular slope, I got to flip it and change the sign. So there we go. And my point A is 2, 5. And all I'm doing is plugging that in. So let me write my point slope. So y minus 5 equals 1/2 x minus 2. So that's in point-slope form. And then they want it in slope-intercept form. So all I'm going to do is distribute that 1/2. So 1/2 x. So I'm distributing this, and 1/2 times -2 is -1. And then I'll add 5. Okay, there we go. Not too bad at all. So this is sort of tying together some things that we've learned. Last one, given the circle whose center is at x plus 4 squared plus, whose equation is x plus 4 squared plus y minus 2 squared equals 136, write the equation of the line tangent to the circle at the point 212. All right, so the center of my circle is -4, 2. The point is 212. So here's the first thing I do. I find the slope. Okay, so 5 minus 2, 2 minus -4. Slope is the change in y over the change in x. And I don't know, I have the wrong point there. So sorry, guys. All right, so let me erase that and start over. So the point was 212. I don't know where the 5 came from. So starting over, 12 minus 2, those are the change in y. 2 minus -4. All right, that gives me 10 over 6, and that reduces to 5/3. Let me just erase this extra little line I had there. Okay. All right, so there's my slope. But remember, this is tangent, so I need the perpendicular slope. I flip it and change the sign. So now I'm going to take this perpendicular slope, and I'm going to take the point, not the center, because I'm writing an equation of that tangent line. And all I'm going to do is plug it in. So y minus 12 equals -3/5 x minus 2. Perfect. Done. All right, so we're going to practice that tomorrow.